You guys lucked out because I had told you only had through lunch tomorrow to get those revisions turned in. Because of the other math class, I realized that wasn't quite fair. I needed to give them a chance to have a session to work on their revisions and whatever else. So I'm updating those today. Those grades are going to drop into math. So if you've turned in revisions, they will get graded, and if they're good, your grade will get changed before they ever get put in math. But for you guys, I'm probably doing that second one. So if you haven't turned in, just leave it now. It's already there. Leave it. Now it has no potential energy. You can get it at the end of class, but why stand it back up to make it fall? I'm always the person continuously fighting things falling over, so eventually we just stop picking it up. Everyone have a resource page from the back? We have 44 seconds left. Please make sure you have that resource page. How are we doing? Happy Valentine's Day. Let's get all of it.
No, it's wrong.
Well, Saint Valentine is a real person, but Valentine's Day in its current iteration is thanks to Hallmark and big candy companies making you feel like you have to buy a heart full of chocolate, or you have to get a card, or you have to get roses, and for some reason those flowers are better than others. My wife likes orchids, thank you. Allie, what's that?
Yeah, Alana was wondering if, since she's in your advisor, if the anonymous Valentine was from you.
What? Never. No. We wouldn't do that to make sure that everybody got candy on one day. Why would we do that? All right, header, solving equations. That's what we're doing today, solving equations. Now, luckily, on that resource page, you've been given some of the work done for you, but it also kind of forces us to make certain choices. So, you and your partner check out what Jean and Aiden were doing with their work. They tell you in the right column what step they took. So if they're missing anything in the left column, you have to take that step. Now, if you can't, like step number 1 says use the distributive property. If one of them has nothing to distribute, then it just stays the same. So you're only following what they tell you to do. Then in 2, how would you have gone from this step to that step? What did they do? So try to fill in your resource page right now with what we've talked about in class, whether we did like 0 pairs or balanced pairs, bless you, combining like terms, all those sorts of things. Try it out. I'll give you 2 to 3 minutes. Try to fill in all of these boxes. On your own. I'm going to randomly call on people for a little bit of help. So, Annika, can I distribute on both sides, or which math can I distribute? Both sides? So what gets distributed in mat A? Why do I need to distribute there? What causes distribution to happen? Do they tell us it's the distributive property here? There we go. Thank you very much for telling me that. Distributive property is of multiplication. So if you forget that, please write that in there. It's the distributive property of multiplication. So what we're distributing here is the fact that we have 2 sets of things we can't combine. Right? I can't combine the 2x with the 1 because they're not like terms. You okay, Al? Okay. So draw these arrows that remind us to do both multiplications, and then write out that order. Now, actually, Annika, there's nothing to distribute on the right side. So the right side is going to stay the same. Mr. Allen, do you need something, sir?
All the little search protectors, hidden cords and things that are in the basket.
We brought them, found them being that we needed them. So they're in a certain James closet or in a DJ closet.
DJ closet.
Like, if you need a key, I
Good
can
morning.
find
Will
it.
Kundu please come to the office? Will Kundu please
Is it
come
just
to the
like the
office?
normal
Thank you.
little
The
silver
closet
key?
with the guitars.
Is it the normal little silver key?
It's like,
Closet.
they're in a flat crate. Jane did know before in that. Then they'd gotten left in the locker room. I grabbed them or something. So I can help you block too if you need. Ella, what do I get when I do 2 times 2x? 4x. And what do I get when I do the 2 times 1? Just 2. Still have that negative 3x. Still have that negative 6. I'm going to use different colors for left and right just to make it like obvious. Nothing changes here. Because they told us we used the distributive property. Questions? How we distributed and got these values from what was right here. Alex, in number 2, do you know a reason of how they could have gotten to 3x plus a negative 4 and 5x plus 3? Combine like terms. Now, another way we can talk about that is 0 pairs, but we won't always make 0, so it's just as nice. It's actually probably better to say combine like terms. So they're like terms, same variable, and same exponent. That doesn't really matter too much yet. We're not doing a bunch with the exponents, except when we do the algebra tiles. Now wait a minute. How did we get just 8? I had 8 above. Alex? There is a 0 pair right in the middle there, so the 8 just kind of carries down. So the positive 3 and the negative 3 cancel.
Good morning. Kimberly Bonk, please come to the office. Kimberly Bonk, please come to the office.
Subtract 3x from both sides. I'm going to write that in, actually, and it's my advice to you that you do the same. I'm going to subtract 3x and subtract 3x, and now I get left with, what's on my left-hand side, Eleanor? Just negative 4. Perfect. And on my right-hand side, Zoe? Yeah, 2x, and then the 8 is not affected. And then they somehow get to negative 12 and just a 2x. Delaney, what do they do to get there? Aside from eat candy carts. That's a good stat, but... Okay, I believe you.
8. You add 8 to the other side. I want to say you subtract from that side, but
How can I do different things? I can't do that. That breaks the math rules. I gotta do the same thing, right? You're hot on the right track. You just got one error in your thinking.
you just add on that.
How do I go from negative 4 to negative 12? You subtract 8 because we isolate the 2x, right? To get the 2x by itself. What did we say yesterday? Like subtraction compared to addition, multiplication compared to division. Those operations that Patrick do the backwards thing? You guys aren't paying attention. What up? Addition compared to subtraction, or division compared to multiplication. Do you remember what we call them? Something operations. I mean, here we subtracted 8. That's not the word I'm looking for. Anybody remember? Ella? You weren't even here yesterday, were you? She wasn't even here!
I was confused.
Say it louder. Inverse operation. Guys, did you watch the video? Well, okay, sweet. So, gold star for you. But, inverse. Guys, when we're talking about, like, undoing or the opposite sort of, like, operation, we're doing the inverse. Okay, inverse operation. So, it's added, we subtract. And then they say divide both sides by 2, so I'm going to show that. On the right side, we get just our x, because that was our goal the whole time. And on the left side, we get -6. Be careful with the sign. Still a mistake that I see with the kids that I tutor. It will always haunt you. Be careful with the sign. Does this entire process make sense to us? Are there any questions why we did what we did? Okay, check out 72 with your partner. Write out the original equation. We got to get in that habit, writing out the original equation. Then solve it. Show your work. I need to make this announcement every class, but from here out, if you see me write SW on anything, it means show work. It means like I'm looking for your work. So that's feedback that I'm stealing from a high school teacher. If I write SW, so give me your eyes for a second. Hear me when I say this, because we want to practice now like we're going to do on the assessments. If you don't show the work for how you solve these equations, this algebra stuff that we're doing, it will be marked wrong. And I will write SW. If you want to complain, you can show your work just live in front of me. I don't care, but I got to know how you get there. Okay, so please show your work. On 72. Yeah, there's a box there. So, Aiden does this work, right? What did he do? So I'm really thinking, I think I got ahead of myself. I think I'm thinking of 73 where we're going to write the whole thing out. Since this is done for us, I'm going to make some decisions on it. Yeah, let's keep rolling. Let's just talk this one through. If you want to write it out, that'd be wonderful. But I'll have you write out the next one because it's a bit more complex. What is, and we can call it a few different things, but what is happening here? I won't even use cards, right? Balanced pairs. Remind us what that means.
That means when you subtract the same amount from your answer, also
Yeah, doing the same thing on both sides, right, to keep things balanced. So balanced pairs there, or we could say inverse operations, right, because he subtracted 4 from both sides. Then, what are we doing here? It's okay that we all have candy, but you can't. So you can, but you got to still be like with us in class. At least in my room, I'm okay with that. I'm not making the statements for everybody else. Patrick, what happens here?
You're dividing
To why?
to make 1x, to figure out how much.
Ah! Please, this is what we want to focus on here. The reason that we're doing this, we just made a giant one. So the point of that last inverse operation, what we normally say for our last step, is to make the 1x. And we don't often show the 1 in front of it. So we're like, and some of you who are getting this a bit quicker are probably sitting here like, why is he like talking in circles? But solving equations is like one of the most important things we're doing this year. So that's why we're taking a lot of time to really understand this. Inverse operations, if there's something being added to the x, we subtract. If there's something being subtracted, we add. Same thing with division, multiplication, all of that. So did he make any mistakes, or are we good? Negative 12 minus 4 looks good. Negative divided by positive. Are we good? How could he check? This will be on your mastery. How could he check, Grant? Starts with an S. It's like when I get sick and somebody else teaches. Substitution. That's how he could check it. All right. Please write this out. We want practice on our notes, so we're going to write this out with them. Or, sorry, that's on your resource page, isn't it? Flip back to your resource page. Forgot about that. Between the steps. This is as if you, or like if you become a teacher someday, and you're trying to figure out what happened to go from here to there to there to there to there. Show the work that's missing. So between, there should be space on there, or you can off to the side, or if you want to copy it down. If you'd like to rewrite it, you can, but we did resource pages. So what happened? We'll give you a couple minutes. Off to the right, you could write the verbal explanation for what's going on. Highlighters, if that would help you. So, Emma, what is happening on the, really on both sides, I guess, to take us from step 1 to step 2?
On the left side, they're adding x plus 6x.
Okay, x plus 6x over here. And on the right side? Yeah, the 5 minus 1 or the negative 1 plus 5. How could we explain that? Like we were trying to write out with words what happened. What did they combine? Like terms, right? So combine like terms. Like terms should start to kind of be one of those all of a sudden. Excuse me. All of a sudden it pops in your head just for no reason, like that song or whatever. You should be thinking, oh, what? I can add bananas with bananas, but no bananas with apples. Now, between step 2 and step 3, some things like disappear. Allie, what do you think is going on between step 2 and step 3, like right in here? Yeah, so that's what happened here. So the next step. Sorry, that was up there. Do you know this one yet? Come back to it. Francesca, do you know what happened between here and there? He added 4 to get rid of the negative 4, so that we could describe as a balanced pair. Right, what we're doing is the same on both sides. Kate? Ooh, he takes 3x away from both sides, so please make sure we're writing that in between the steps now. It's kind of hard to show combining the like terms, so I just kind of draw the connection. But everything else we can show that work.
Good morning, Sean Ferdinand, please come to the office. Sean Ferdinand, please come to the office. Thank you.
Cupid to the office. We're going to do group answer on this. And I don't want it to hurt my heart, right? I'd like to know that we're awake and we know what's going on. Group answer, what happens here? I love how I say group answer. Yeah, divide by 4, right? People said it. Thank you very much. We do that division by 4 to make 1x. Because we're trying to solve for what is the value of 1x. And we get 2. So that is the division property of equality, but I'm not worried about you guys being able to define that right now. Just as long as you realize like we're doing the same thing on both sides. It's still actually a balanced operation. It's not really a balanced pair, but it's balanced division. Like balanced split, whatever you want to say. Balanced reteaming, regrouping. Questions? Hard. Don't know. Still working on that one. I've heard it's 23. So what you're telling me. Sorry, 23 is Dr. Pepper. Or no, 20. No, 57 is Heinz Ketchup. Numbers that mean things. Nobody has any questions with this entire process. Everything makes sense. Try 74, parts A and B. Part B, you're going to have some options with how you deal with that. Try parts A and B. Be careful. B is not exactly like what we did yesterday. So although you have options, it kind of there is a better choice. And it's not the same sort of thing as we did yesterday. So we got to write this out in our notes. So please write the original equation. Don't try to combine any like terms as you take it from your book to the paper. Just write it exactly how it's given to you. Then start working with it. Now, it's helpful to some people to draw a little dotted line down the middle to separate your left and your right side, kind of like what we had with the equation map. Because then it is nice and easy to say, well, if I do it on one side, I got to do it on the other. All right, I'll give you guys a few minutes. You can do whatever you want as long as you do it on both sides. You could bring in x's if you want. You could take away tiles. A is solvable. There is a value for x. Don't use a calculator. I do not advise using a calculator. All right. Back to cards. Nathan, what's the first thing that you would do here?
Like terms.
Always look for like terms. Nathan just had this. Yeah, always look for like terms because that is going to start your work the easiest. Don't start doing stuff on both sides, like taking things. Look for like terms first. So Patrick brought up a good point. Like, wait, positive, those are zero pair, right? And these are zero pair, and we just end up with zero over here. But that doesn't mean that we don't have a solution. That just means right now there's no tiles over there. On the right side are like terms. What happens here? Zero, so then the 2 is just going to come down. So I should write that in purple. And the 6x, does he have any like terms? Not anywhere, not on this side, not anywhere. Now this is where they expect you to get stuck. Who, let's just be honest, hold on, let's just be honest. Who hit this point and you were like, well, I'm like, it's over, right? I got, like, I can't do. That's what they want you to realize 0 is a number. It means there's no 1 tiles, no x tiles, but that's for right now. Okay? Thank you, Kate. This is not 1. This is negative 1. Who missed this sign when you copied it to your paper? Who, even though you had that sign, because this one was in parentheses, told yourself that these were going to be 0? I asked the question. You guys told me. I said, what happens here? And you said, or maybe I even said it. But as I walked around, people are making 0 pairs. This isn't 0. That's negative 2.
You're 0.
So wait a minute. If that's negative 2, and this is positive 2, wait, so this is, oh wait, crap, this is, now, even if you got to this point, we're not done quite yet. Now, if you're good at math and you're like, okay, something times something equals 0, one of those somethings has to be 0. But if we follow the process, what work would we show next? Alex? Divides by 6. And 0 divided by 6 is 0. There's our proof that x equals 0. Now, I wanted to talk for a moment because as I walked around, I saw on people's work. Let's talk about what if we had 0 equals 6x plus 2. I'm going to go rogue for a minute. Some people hit this, they raise their hand, they're like, so what do I do here? That just means that this number plus that number is 0. That's math we can do. What sort of numbers add up to 0? What pair of numbers will make 0? We call those additive inverses. What does 6x have to be? Negative 2. Because guys, think about this for a second. If we're not just trying to follow the steps of the process, thank you, Jeff. If we're looking at this is a number, give me a second, and we add 2 to it to make 0, this has to be negative 2. The algebraic process, what we would do here, and if you had this work, it was wrong, but it's okay. We would just take this 2 away from both sides. You can take 2 away from 0, right? You can work with 0. It's still a number. So this becomes negative 2 equals 6x. And then, and a few people did this, and they got like a repeating decimal answer. If you do the division by 6, you would, and this is not the right answer, so let's say that again, but if you went this route, you got an answer of negative 1/3. But be careful, -1 and -1 aren't a zero pair up there. They make a zero pair with the 2. So yeah, be careful. Questions? If you haven't done B, do B. If you've done B, move on. So those friends, quantity, right? What's that? I only heard it. Sounds like these are 2 different terms. So that's a variable. That's a constant. Like, 'cause that's, we don't know that that's a constant. So if you know the constant, you gotta take it away from it. So you're good. I got a pencil up here. What are we doing? Huh? Looks good. Okay, so you took everything away from the inside. So are you stuck here? So now we have very well. Now make sure you carry the equal sign. You need X on one side and the numbers on the other side. So how can you get that 6 off of this side? Yeah, subtract it. Subtract from here and turn the right side into me. Huh? Can you what? Can you catch? So I'm gonna erase it first.
No.
Look at that! Good work. Alright. I'll attribute that to your athletic skills because it sure wasn't mine. First thing we do, one option is distribute. Now, hold up. Who thought back to like yesterday and thought, well, maybe I could divide first? Anybody? No? Did we just totally block out yesterday? Okay, so we could here. That's an option, but hold on. Give me your eyes for a second. Because we did this yesterday, I wanted to show this. If we don't want to multiply and we try to divide, everything over here gets divided, and we then end up with x divided by 3. Don't erase fire, stop. Don't actually write this. This is not a good route to take. On this problem, this makes things complicated. Because then x will be divided by 3, and that's not very nice. So you have to make the choice of which you think is the best option. So if we distribute, which most of you guys did as I walked around, we got 12 plus 3x equals x plus 6. Nothing happened on the right side. Penelope, what could I do on both sides? I'd like to hear from Penelope if she knows, but if not, she can hand it off. You don't know? Sure. You have 4 options here, guys. You literally have 4 correct options here. Give me your eyes for a second. You could take away 12 from both sides. You could take away 3x from both sides. You could take away x from both sides. You could take away 6 from both sides. You seriously have 4 correct options, so please don't erase if you took a different route. You said take x off each side. All right, so now we have 12 plus 2x equals 6. Okay, Kate, what next? Ooh. We're not going to divide yet. We don't have everything grouped together. We don't really want to divide until we group. So, I saw a couple of people do this. I could take away 6 here, but then I end up with nothing over here and everything over there, and that's just kind of complicated. So you could, but it's not the best choice because you're going to make more work for yourself. Alex? If I take away 12, remember this is just a plus 12. It's a positive 12. (2x equals -6). Now, because I have a variable side and a constant side, now we can divide. Because once I divide, I want the x to be by itself. -3. Question? Preguntas? Try. Anyone want to stick around? Go to 76. Look at B. Let's do 76 part B real quick. 76 part B. Write it on your paper. Show your work. Work with your partner. All right, we got 4 minutes left. Here's my challenge to you. Do not look up here unless you get stuck or you get the answer. Okay? Eyes on your paper. You're doing your work. the sake of time, we gotta start talking about this. So, Emily, what did we do first? What are my red arrows showing? Yeah. Distributed the 3. We did distributive multiplication. Okay, so my red arrows showed the distribution. Alan, what did I do with my green arrows?
Like terms.
Like terms. Combine those like terms. Watch out for the signs. That's what catches most people. I think I did that correctly. Matt, what did I do next? Balanced pairs to get the +5 off the left side. You didn't have to follow that route. I see erasers going. You didn't have to take that route. There were 4 routes available there. Grant, what did I do next? Here. So I added X on both balanced pairs, right? So inverse operation balanced pairs. This gets rid of the negative X. But now I have negative X equals negative 8. What does that actually tell me about X? If I want to turn X into a positive, what could I multiply it by? Not X. -1, right? Please show this work. If you have a negative X and you want to make it positive, just think, what's the opposite? Well, some of you figured out, well, if negative X is -8, positive X is positive 8. But we want to make sure we understand why. We, again, did the same thing on both sides. Out of time. Have a great day. Remember, we have a mini mastery coming. Either tomorrow or Friday. Probably Friday because of the weird schedule with Friday creative option. We'll just do it Friday. Thank you guys.
Wow, cool!
Wow, cool.